Okay, so in this triangle PQR, we know that PQ is 6. So here's 6. We'll make this Q and this P. And this is long, and I know this is 30 degrees. And PR Q. Okay, so Mr. Rops here. And in this triangle PQR, we have PQ is 6, PR is K, and angle Q is 30. So here is, let's say, Q, and here is P, and this is 6. And I know PR is going to be over here somewhere, and so this is going to be QR, so here's my angle of 30 degrees. And here is going to be my R. And this is K. In this first case, K is going to be 4. And so it wants me to find the two possible values for KR. Well, the easiest way to find this is if I use the cosine law, and if I say that the 4, this cosine law, that the side and the angle have to go hand in hand. So it's going to be 4 squared is equal to 6 squared plus the QR squared minus 2 times 6 times QR cosine of 30 degrees. So rearranging this, I know that QR squared minus 12 cosine 30 QR, and that's going to be 36 minus 16. 36 minus 16 is going to be plus 20 is equal to 0. And so now using my calculator, I can find the two different values of QR. If I just go to my polysimultaneous, it's going to be number 1. Again, I'm checking to make sure I'm in degrees, which I am. And I get 1. I get negative 12 cosine of 30. And I have 20. And I solve that, and my two values for QR are 7.8419, and I get QR is equal to 2.5504. So the three significant figures, it's approximately 2.55 and approximately 7.84. Okay, so that is A part. Now B part, I want to know the values of K so I get a unique triangle. That means that there is only one possible triangle. Here, there's two possible triangles. I can have this KR or I could have this KR. And so for me, this is really a visualization problem. And so what I'm going to do is I'm going to draw this again. I'm going to go, here is my scenario here. And I'm going to call this Q, and this R, and this is 6, and this is 30. And I know that this side here, oh, sorry, that's not R, that's P. Here is P. I know this side here is R. And this is the length that can change. I know if it gets short, and I get it so that it is a 90-degree angle, because if I have, here, let me see if I can do it with a circle here. One of the things I could do, if I take my circle tool, and if I look here, at this point there is one triangle. At this point here, there's two triangles, two triangles, two triangles, two triangles, two triangles, two triangles, all these are two triangles, two. Here's still two. Now I go to one triangle and only one triangle. Over here is the point of intersection here. So if I undo that, so if I look at my circle, the first one here, all these small values there's no triangle. At that point there is where there is one triangle. And so here, that happens at 90 degrees. And so this is K. And so if I want to know what K is for this one triangle, well, I can use sine of 30 degrees is equal to K over 6, opposite of hypotenuse. And so K is equal to 6 sine 30. And I know this is a half because I've memorized that, times 6. K is 3. So that's one possible value. But if I come along and I take this and I extend it out, which that's not going to work, let's just draw a new circle. Right, when I draw this circle, so there's a split second, there's 1. Now these are all 2, 2, 2, 2, 2, 2. It's only after here, where here is my one triangle. Here is the triangle out to here. If I would go P to Q to R, it's too far. And if I keep extending this, it's bigger than that. So that happens when the radius is the same as this. So when K is bigger than 6, then I also know I have a unique triangle. And so using this idea here of my circle, I can also visually see that there's two triangles, two triangles, two triangles here. There's two triangles. Only when I am further out to the side, when these are further out, when it's bigger than 6, is there one triangle. So there are two solutions, or two parts of the solution. One is K is 3, and the other is K is bigger than 6.